Let us now do a strategic review of section 16, computer systems. When we compare to the topic that we wrapped up not so long ago, computer networks, when you look at computer systems, it is actually about the same weightage as control systems. And these are sort of the intermediate topics in terms of their weightage. On one extreme, you have the big five, and the other extreme, you have ethics and computer networks, which are the lighter topics. And in between, you have topics such as computer systems, you have topics such as control systems, which are neither heavy nor light, right? Only 1.5, 2 pages for this topic, despite it being heavier on the exam, according to the exam specification, than computer networks. So we all know the issues around computer networks preparation. When it comes to computer systems, it also has some eccentricities, some quirks, some nuances. Starting from microprocessors. Now, microprocessor, I think in one of my live trainings, I actually showed the students like a 800-page textbook that I use in my undergraduate coursework to take a course on microprocessors. And it is a world in itself. Okay, so things like Arduino programming, there's a lab component to it, there's machine level programming, so assembly programming. So it's just a lot of content. Now, when you look at the reference handbook, they barely scratch the surface. All they talk about briefly is RISC, and that too, CISC, not as part of the main content, but under abbreviations, right? So what I've done is that I have given you an architecture of Intel, I think 8085 or 8086, and explained you different components within that. And then we made a distinction between microprocessors, controllers, and computers. You looked at different terminology in the hope that, and all addressing modes and whatnot, in the hope and expectation that it will bring your preparation above average, right? But this is a wild card. So I don't want to take the approach of converting my undergraduate course, for example, or going too deep into microprocessor, because I think that this is, at the end of the day, still a subtopic within a relatively small topic. Okay. So follow the lead that I've provided you, the content in the on-demand, and I think you should be set. Architecture interfacing, a lot of these are very conceptual topics with some practical application. For example, how do we organize the control unit? How do we organize the arithmetic and logic unit? And most importantly, the memories. Okay, and that's the distinction between Harvard and Princeton. Single core versus multi-core. We all have computers, processors, even the cell phones that we have today are far more powerful than the PCs that we used to have 10 years ago. Okay. Threading, I've explained the concept, and this comes into play. We've looked at this in the context of communications, I believe, or signal process communications, when we compare TDM, time division multiplexing, and frequency division multiplexing. Frequency division multiplexing was true multitasking, whereas time division multiplexing is basically a single core processor running multiple threads and essentially exchanging the processing capacity between different processes. Okay. Again, pretty plug and check type of stuff, primary versus secondary memories, RAM, different types of ROMs. So a lot of stuff, information is given in the reference handbook, in the on-demand as well. I go through that in detail. But the real deal is cache, correct? Memory. So when you're talking about the replacement policies, LRU, FI, FIFO, LFU, random, this is where you have to conceptually think. We've done some interesting practice problems, which in my opinion are probably beyond what you'll be tested on the exam. But when you understand this inside out, you'll be set. Write policies, write through and write back. We've discussed them in detail. What are the advantages, disadvantages in terms of speed, in terms of accuracy, in terms of backup, in terms of data loss and whatnot. And my personal favorite topic within computer systems, as I mentioned in the live training, is mapping techniques. The reference handbook just gives you this formula and a few one-line items around different types of bits. Okay, index bits and block bits and the addressing bits and tag bits and whatnot, without making a connection with fully associative, NVSAT associative, and direct mapping. When you go through the live training program specifically, and even in the on-demand, I don't think that you can arrive at level 3 understanding, which is holistic understanding, without visualization. We need to be able to literally make connections between different memory blocks after we are told what type of mapping technique we are using. And I went out of my way in order to help you guys understand this in the program. And once you have that level of understanding, no matter how a question is asked, you'll be set. The other thing that you have to be mindful of when you're dealing with problems related to computer systems is the fact that the units of measurement, kilo, mega, and giga, and so on, they are different in the binary world. And I've emphasized this, but I'm repeating it again because I routinely receive emails from students where they're like, okay, Wasim, I did this problem, but my numbers are not adding up. And a common mistake is that they're confusing SI units with the binary. In the system international world, kilo is 10 raised to power 3, mega is 10 to power 6, and giga is 10 raised to power 9, and so on. In the binary world, what is a kilo? Kilobyte. What is it, guys? 2 to the power of, help me here. 2 to the power of, no, not to the power of 3. 10. What is a mega? 2 to the power of 20. You see a pattern over here? 2 to the power of 30, and so on. As simple as this concept is, okay, when you're starting to calculate the number of bits for cache memory, if you mess this up, okay, you don't stand a chance to get the right answer despite having the right concepts and despite having all of that visualization and understanding and derivations and whatnot. So please do not make this mistake. This will be a very unfortunate way of losing points on the exam, and especially at the tail end. Section 16. This is like when you are supposed to power through, keep the momentum going, right? And finish off at a high. Whenever you see any sports, any game, basketball, soccer, American football, any game for that reason, what happens in the last few minutes? Both teams are going crazy, right? It almost seems as if they were holding their best for the last. You don't want to be missing easy points on the exam, especially in sections close to the end. Okay. And this is one of those examples where students make mistakes. And hopefully, when you go through the content, on demand, quizzes, live training, study guide problems, homework assignments, that you will be cognizant of it and you'll be on an extra, extra aware, extra alert for not making these mistakes. And if you want to learn more about preparation of FE Electrical and Computer exam and the P-Power exam, then check out these playlists over here. Thanks for watching, and I'll see you soon in the next video.